Welcome to today's presentation, dear viewer. Now, today we are going to look at indices, and our question reads, without using a mathematical table or calculator, evaluate 6 power 2x plus 1 is equal to 2 power 2x plus 1. So, as we can see in this particular problem, the bases in this case are not the same, and therefore it kind of becomes difficult to find the value of x. So what I want us to do is just to ensure that we make the bases similar. And how can we achieve that on the left hand side and the right hand side? Now you can see that 2 is one of the factors of 6, and we expect to express 6 as 2 times 3. That is 6, and that is raised to power 2x plus 1. For the right hand side, we can also apply the same. We'll have 2 times 3, 2 power something times 3 power something, and still have to maintain the right hand side the way it is. So what are we going to do here? So we can say 2 times 1, or rather, let's just have it 2 times 1 raised to power 2x plus 1. Now, 1 here can also be expressed. Remember, our goal is to express this bracket as 2 times 3. So we are going to achieve that as follows. We have 2 times 3, but 3 here has to be raised to power 0. So if you have a number raised to 0, that will always give us 1. So this 1 here, we are going to replace with 3 power 0, but still we'll have to raise it to power 2x plus 1. So we are interested in this and that. So those two, we can now equate them. So we have 2 times 3 raised to power 2x plus 1. And then on the right hand side, we now have 2 times 3 power 0 raised to power 2x plus 1. Remember, by laws of indices, we can have, if we have, for example, a power m raised to n, this is just the same as having a power m times n. So we multiply the powers. Similarly, if we have inside the bracket a times b raised to power m, remember a is here to power 1, b is raised to power 1. So we'll have to multiply every power of what we are multiplying in the brackets by the power outside. So we'll have a raised to power m, that is m times 1. And then times b raised to power 1, and 1 multiplies by m to give us m. That is exactly what you are going to apply on the right hand, or rather left hand side and right hand side. So we are going to have 2x plus 1 multiplying by the power here. Remember, this is power 1, this power 1, here also power 1. But for 3, we have 3 power 0. So when we multiply, we'll have 2 power 2x plus 1 times 3 power 2x plus 1. And then on the right hand side, we will have 2 power 2x plus 1 times 3 power 0. Remember, 0 times 2x plus 1 is just 0. So at this particular case, we can see that 2 power 2x plus 1 and 2 power 2x plus 1 appear both on right hand side and left hand side. So that means we can divide both sides by this. So we have here 2 power 2x plus 1, and this side also by 2 power 2x plus 1. So this cancels with that, like that, and then we finally have 3 power 2x plus 1 equated to the right hand side. We have 3 power 0. So at this particular point, the bases are the same, and if the bases are the same, we can therefore equate the powers, you drop the bases, so we have 2x plus 1 is equal to 0. And then from here, we therefore proceed to get the value of x. X is negative a half. Well, that is how we go about this problem. So once again, I want to thank you for watching. Just hope to see you in the next video.